Start. We're just going to go through this thing, electrical 2 test 6, and some of this stuff is going to sound fairly interesting. This is the starters and whatnot. So let's go ahead and get started here. Most noise from starters can be traced to starter drives. That's true. Starter drives? Yeah, starter drives the gear and the overrunning clutch part of it up in the front. There's a one-way clutch is connected to that gear, and whenever the engine starts up, it lets that gear spin up. And so the engine's going to pick up faster. Usually, and this is a sort of a generic statement, but the ratio of gear teeth to gear teeth is like 14 to 1. The starter's got 1/14 as many teeth usually as a flywheel. It may go up and down from there a little bit, but whatever. But it's starter drives. Have you ever heard of starter? Whenever on an older vehicle, go wah 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 wah. That's because it's got a bad starter drive. That little overrunning clutch in the starter drive, it gets to a certain point and it just lets it freewheel. And so if you replace the starter drive on one that's doing that, it'll fix it.
Is that the solenoid?
No, the starter drive is the gear that's in the front. Yeah, the solenoid is actually the part that's got the terminals on it.
We always said that was a solenoid.
No, that's not the solenoid. That's actually the starter drive itself. And then back when I first started working on cars, like when I was at a gas station, and then I went out shopping, and then even when I was working in Texas, we would rebuild starters and alternators just all the time. That has gone away. There are shops that rebuild starters and alternators, and that's all they do. But for the most part, it's a foreign thing for mechanics to rebuild alternator or starter anymore. But we used to do it all the time. I mean, the industry's changed over the last 35 years. If an automatic transmission vehicle will start in any gear, the neutral safety switch is probably at fault. That's true. There should be a 2-minute wait between cranking attempts. Technically, that's right because you don't want to get the starter too hot. But incidentally, that problem where that little neon tried to take off the other day whenever it was started up and all, when Webb was working on it, you remember that little the shift cable on that thing, somebody put the shift cable on there and they had it laying on the catalytic converter and it burned it up. And that's when Lundy pulled it off, that's what he found. And the shift cable was all locked up.
It was melted.
Yeah, and so what we have to do, I got another shift cable coming for it. We got to put it on there.
Okay, that safety, what you call neutral safety switch?
Yeah.
Now, that one, that's what was on that Lexus. When I tried to crank it, it wouldn't crank at all.
Unless you put it in neutral. You know what I mean? Like if you've got one that's got, if you got one that won't start in park, I always drop it into neutral, see if it'll start. And if it'll start in neutral, it won't start in park, it's either out of adjustment or it needs a switch. Now that won't typically make, the kind of failure they're describing here is atypical. You don't usually see a neutral safety switch fail that's going to let it start all the time. Ordinarily the neutral, and they didn't have neutral safety switches, until I think the 80s or something, or maybe the 70s. My mother had a 66 Chrysler that didn't have a neutral safety switch on it. You could put it in reverse or whatever you wanted to and drive off with it. They also didn't have the ignition lock connected to the steering wheel in those days. You could actually just get in there without the key in it, put it in gear, just whatever, turn the steering wheel. And the steering wheel lock came about in the really late 60s. Chevrolet started it in 69, and I think Ford started it in 70 on their cars. Pickup trucks didn't have it, in vans for quite a few years after that. And they eventually all started putting them on the column. And, tying the shift interlock to where somebody couldn't reach over and just switch a key off going down the road and pull the key out. I mean, they could do that in the old days, but it didn't matter because all you had to do was just drive the car over the side of the road. But if the key got jerked out accidentally on one of the other ones, so you can't even go, if you're in drive, you can't go all the way back to where the key will come out. I mean, that's a safety thing. It's really surprising how much that kind of stuff they do. All right, now, slower than normal cranking speed will result in lower than normal amperage. That's false. Always remember this too, and I've mentioned this before, and I'm always hammering on it. If you're spinning a car, an engine over, and it may sound like it's spinning okay, but if that voltage is going below a certain threshold, the engine controller won't even operate the injectors if the voltage is going below a certain threshold. Like on that Ranger sometimes, there'll be enough juice in a battery to spin the car, spin it over, but there won't be enough to start it. All right. Slower than normal speed and higher than normal cranking amperage is usually a result of internal starter problems. No, not typically. The ring gear teeth of a flywheel are badly worn in various spots. Technician A says this could cause poor drive gear engagement. Technician B says this could cause a lower than normal starter current draw. That's A, actually. Yeah, that's A. Poor drive gear engagement. You got worn out teeth, man. Your drive gear's got to engage your teeth. I'll tell you something else too that was taught to me by the guy that I worked for at that gas station back in the mid-70s. Usually, when you switch an engine off, it stops in about the same place or one of two places. You know, if you actually mark this flywheel, you know, and you can get one where you can watch it. Let's say you just walk under there the last time somebody shut it off, and you make a mark, and you crank it up and you shut it off. You got a really good chance of seeing that same mark stopping about that same place. And so that's why your starter will hit the teeth in about the same place, you know, every time, just about, or within about 6-inch range.
Hey Rich, that reminds me, did you ever get a starter for that motor over there?
It's already been put on.
Okay.
Yeah, Real Cowboys fixed that one. Okay. Yeah. Ring gear teeth of a flywheel are badly worn. Oh, never mind, I've already read that question. Duh. What should be done to the system when a 7/10 of a volt drop is observed between the battery top positive terminal and the starter solenoid with the engine cranking? What do you think?
It's a lot of volts.
Replace the cable or 7/10 of a volt. Rotate. Well, you remember that one that we had out here that had that Chevrolet that had the scorched terminal on the, and we would put a solder on terminal on it and all that. I got pictures of it on my Facebook Technical Writer page. Really, somehow when I post photos, really good clear photos on my Technical Writer page, I'll get 7 views. But if I post a bunch of text, I get 86. You understand what I'm saying? I guess people are just tired of looking at pictures and they just want to read something. Or, you know, it's just weird. It might be the other way around, don't it? But anyway, we actually had 9/10 of a volt, and she was having trouble starting it. And when we went ahead and put that solder on terminal, we got that voltage from 9/10 of a volt down to 1/10 of a volt. The starter, the voltage drop went away. And you guys understand what voltage drop is. Whenever you measure between 2 points on the same side of the circuit, I'm talking about you go to the battery terminal, and you go to the starter, right? Hot battery terminal to the starter, looks like you're measuring all the same thing. If you see any voltage show up in there that you're dropping, that's a voltage drop. That's how much you're losing because of resistance or whatever. All right, that's a big deal. You need to burn that in. All the following could prevent a starter solenoid from engaging except what? A, an open neutral safety switch. B, a shorted clutch safety switch. C, a bent armature shaft. Or D, an open ignition switch. What do you think about a bent armature shaft? It's not going to keep it solenoid from engaging. It's going to, you know, it'll engage even if it doesn't do anything when it does. And remember now, and I've said this before, but I like to say it again, if you got one that you're hearing go click, 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 and it won't spin over, that doesn't necessarily mean the starter is bad. I've told you that story about that girl. She called me, she was enrolled in a program. She called and she said, I'm not going to be able to be there today because my daddy got to get a starter for my car. And I said, we can put a starter in the car, drag it over here. So she drags it over here, and it goes tonk, 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 and it was making a noise. Just the starter would click in, you know. We had good, strong battery. You can see the cables go, you know. If them cables are actually got a lot of juice flowing through them, you know, they'll move. You know, I don't know, you ever seen battery cables do that? When a lot of juice is going through them, the cable, there's so much going through there that they actually tighten up and they move a little bit because of all that induction. But anyway, we got a breaker bar we put on the crankshaft pulley, and Hunter, you know, big muscled up Hunter, he could barely turn that thing. And when I looked down there, I saw the belt slipping on the air conditioner compressor clutch pulley. That bearing is locked up in there, so we took the belt off and it fired up. Now you can condemn a starter when you should have actually wanted to take. You know, we took the belt off and found out the starter wasn't bad, and we managed to get an old bearing out of an old compressor that we had over put in there so she could drive the car, and so it didn't cost a whole lot of anything. And you can actually get a replacement, and Belinda, you may have sold those things. You can get a replacement unit for your air conditioner compressor that replaces the compressor with a pulley. It's got a bearing in it. You just take the compressor off, it bolts right up where the compressor goes, it's got a pulley the same size. And if you don't, you know, like if you don't want to have to buy a $400 air conditioner compressor, you don't care if your AC works or not, but you need to drive the car, they're made that way. Now those things are kind of pricey, you know. And,
what, the little kit thing is pricey?
Yeah, the little kit thing's, well, $100 or something. It's not, it ain't cheap. Yeah.
I do have a power steering and keep my horse.
It's easier to get a short belt.
Huh?
It's sometimes it's easier just to get a short belt.
Yeah, sometimes you can bypass the AC compressor by getting a shorter belt, but it doesn't work on every car. And here's something else that's crazy about belts and stuff. We've actually, Bert brought his uncle's vehicle in here one time, and it was a Cadillac, and somebody had just kept rerouting that belt until they found a way that it would work. And it was like nothing like it was supposed to be, and it just confused the crud out of us, you know. Yeah, they found a belt that was long enough to where they could get it to work if they routed it this way and that and the other way. It's just crazy, you know, how that went. Anyway, let me see. Vehicle being checked for no crank. A voltmeter placed across the contacts of the starter solenoid indicates 12 volts when ignition is turned to the start position. A distinct click noise is heard coming from the solenoid at the same time. Technician A says the starter motor may have an open armature or field current. Technician B says the solenoid needs to be replaced. Now, those wordy questions like that, you know, you got to parse all that stuff and figure out what they're saying. Okay, so we're placing it across the contacts of the starter solenoid. Okay, so let's look at that. Okay, here's the starter solenoid. Here's your little wire. You know, one wire will say S and the other wire will say I on some starter solenoids. But we're just going to get rid of this I because all that does is produce 12 volts when you turn it to start. Okay, this one here is coming from the battery, and this one here is strapped right into the body of the starter, right? Okay, so we're going to put a voltmeter here and here. This is what this question means to me. If I was to read this, and you're reading 12 right there when you turn the key.
That means 12 volts.
You're reading 12 volts between here and here. Now you're going to read 12 volts there anyway because the starter is grounded and the windings in the starter, you know, going through the brushes and all, you're going to read 12 volts right there. Now see, this is, I don't like the way that's worded. A voltmeter placed across the contacts of the starter solenoid indicates 12 volts when it's turned to start. A distinct click is heard coming from the solenoid at the same time. Alright, we're hearing, when this wire right here gets hot, which this wire right here is coming from your, you know, through your neutral safety switch and, you know, your ignition switch and all that. If that right there is clicking the solenoid, but you're reading 12 volts right there. Alright, what do you see? Distinct click noise is heard coming from the solenoid at the same time. Technician A says the starter motor may have an open armature or field current. Well, that's not really so, because would you read the 12 volts there if you're going from here to here? No, if this is open down here, because that's got to be closed before you get a ground available to that terminal. Got me? All right, so, all right, then right here, technician B says the starter solenoid needs to be replaced. Well, now wait a minute, number 9, you know, that's actually B. The solenoid needs to be replaced because why? Because even though it's energizing the solenoid, it's clicking and it's trying to put power, you know, it actually has a big copper washer that slaps against both of these posts and carries juice into the starter. If that's scorched and it's not making contact anymore, you'll continue to read 12 volts here, even though this is making a click noise. You got me? Because if you do a cross section of that, you go in from the side, you got this right here. This is inside. This is what you're looking at inside the solenoid. This is a solenoid. Alright, you got a copper washer right here. And it's basically designed so the solenoid, whenever you energize the solenoid, those windings will cram this thing against these two right here. And it's supposed to have current that flows into the starter, which is down here. If that click is happening, but you're not getting any starter operation, I'm going to jump power down here with my jumper cables. I'm going to bypass this sucker and I'm going to jump power right to there, and the starter will go, wheeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeeee Okay, you were supposed to have, cause I put one in there just now. Did anybody get Demetrius's test for that? I put one in there just a few minutes ago. I mean, cause I was feeding them through there, and I remember looking at your number and putting your test in your box. And all that. Get one out of, a box and tell me which box you got it out of. You know, and we'll get you fixed up on that. But there was a test in your box. I put one in there.
7.
Huh?
Got one out of 7.
Out of 7, alright, that's one that you're gonna be using there. Alright, the overrunning clutch protects the armature from what? spinning too slow, spinning too fast, electrical short, starting the vehicle while it's in drive. That's actually what's going to happen if you got this overrunning clutch. If you don't have an overrunning clutch and somebody stays on the starter, it's going to stay engaged and it's going to spin that armature up to warp speed, isn't it? And it's probably going to warp something while it's doing it. So you got the overrunning clutch. And that's making all that raggle. You know. I fixed my aunt's car in here one day so that it would run better than it was running, and whenever she got ready to back it out, it was running so good she couldn't even hear it, and she tried to start it again. Alright, but that's what that overrunning clutch is for. Let me see, which of the following statements is true of solenoids? They use the electromagnetic field of a coil to pull the plunger into the coil. They are generally used to engage the starter motor with the engine flywheel. They operate it with a movable plunger and usually do a mechanical job. That's everything. We're talking starter solenoids now. There's other solenoids too. Somebody bump that air conditioner down 1 degree. Technician A says 2 windings of the solenoid are called the pull-in and hold-in windings. Technician B says both windings of the solenoid are continually energized anytime the ignition switch is in the start position and the starter motor is spinning. That's A. Got it? The overrunning clutch accomplishes which of the following? A. Separates the starter motor from the flywheel. B. Brings the starter motor to contact with the flywheel. C. Protects the starter motor from spinning too rapidly, and that's actually all of the above, believe it or not. I don't really, well, some of that stuff brings the starter motor into contact with the flywheel. I don't really like that, but I guess it works because the motor actually locks that clutch in and starts spinning it, so I guess you could build a case for that. Some of these questions are really something. The starting safety switch is also called what? Neutral start switch, that's right. And the clutch switch, you know, is, they don't really call it a neutral start switch, they call it a clutch safety switch. On some of your four-wheel drive Nissans and stuff, you can override that if you've got a clutch switch. If you're in a four-wheel drive situation, sometimes you don't need that. So you got to push, you can push a button on some of the little Nissan and they'll let you over.
Like that.
Yeah. And if it's four-wheel drive, you may find yourself in a set of circumstances where you have to bypass that. And it's factory installed, basically. But I told that story one time about how somebody pulled another car. Every time I pulled a car on my rack when I was at a Volkswagen place, I put it in neutral so I could move it around and get it right on the lift. And it's just, you do, you know, 15, 20 cars a day, you just don't think anything about it. You're always doing things the same way. This other guy pulled one in for me, that one of the other mechanics, and he left it in gear, and it didn't have a new, that year model 83 didn't have a a clutch switch on it. And he says, oh, don't forget to set the idle speed or whatever. I had done whatever I did without even starting the engine. And when I started it up, it took off and ran into the wall. Where, you know, of course, I should have felt it. It's just one of them things where you're always used to doing everything the same way, you know. If anybody had been standing there to hurt them. As it was, it broke the block wall and pushed the file cabinets in the office. Scared that lady in there to death. Didn't hurt the car, believe it or not. The car didn't have a scratch on it. But it caved in that block wall. I thought it had destroyed the front of the car. I said, oh, goodness, we're going to have all kind of body damage. But when I backed it out, it looked just so pristine and perfect. You know, had them old bumpers that made the dwing, you know, bounce off and stuff. Yeah, that one was. But let's see.
They were built to survive torture.
Huh?
They were built to survive torture.
Yeah, they were. Those were really good vehicles. The way that they were built, they had a hardened crash cage in here, and they also were set so that if you hit something really hard, it was another car. They had accordion, you know, designed frame so that it would take the impact and the engine would go out the bottom if you hit something really hard instead of coming in the car with you. They were pretty smart about the way they put those things together. Let me see, where are we at here?
15.
Technician A says a full battery test series should be done before testing the starting system. How many times do you see somebody throw a starter on there whenever they had a weak battery? Technician B says the internal condition of the engine has little effect on the operating and starting system. That basically is A. If the engine is hard to spin, what is what is a problem your engine can have where it makes it hard to spin, but it's not anything really wrong with the engine? You think anything?
Make it harder to spin.
Yeah, it's harder to spin, but there's not anything wrong with the engine. Somebody puts oil in there that's too thick, and it's winter, and it's like molasses, you know, really heavy, like 50 weight motor oil or something. Because it's that crankshaft having to churn through that old thick oil, and it'll cause your, you know, starter to work too hard. That's why we have multi-viscosity oil, so that it'll be easy to, you know, spin in the winter. And a lot of his stuff has got 5W30 oil in it now and all that too. But they try to make it so that it will work all the way up north and all the way down to Miami. It'll work in both areas without having to put different oil in different areas. In my Jeep, I just put 2050 castor oil all the time, you know. You know, that wasn't what it called for, but that's what I poured in it, you know. Let me see, where are we at here?
16.
Which one, 15?
16.
16. Technician A says the neutral safety switch can apply ground to the starter relay. Technician B says the neutral safety switch can also control the backup lights on the vehicle. That's right. Sometimes you can take, if you're trying to adjust it, you can put the car in reverse and you can watch the backup lights and you can loosen those screws and turn that switch until the backup lights come on. You'll be really close.
That's what Will showed me that.
Yeah. Yeah, because it's the same switch typically. I will tell you this though, there are some of these neutral safety switches that, well, like on that gold car out there that we got. When those cars were new, we would see some that whenever you would put them in gear, the radio and everything would go off. I mean, you know, it would be the same set of circumstances. You know, when you turn the car to start, your blower motor won't work and your radio won't work and all that. While you're in the start position, it shuts everything down and puts everything to the starter, right? Well, on those later model Fords, that was done electronically on some of them, like on that Taurus. And if the neutral safety switch was internally shorted, you'd be sitting here listening to your radio and enjoying your blower, you know, blowing on your air, cool air on you. When you put it in gear, you'd lose all that. You put it back in park, it'd come back. And it's because it was internally shorted and it was sending a signal to the GEM module or whatever, you know, and it would shut a bunch of stuff down. You know, it was a strange thing. I never tracked exactly why that happened. We replaced a lot of neutral safety switches because they were, you know, shorting things out and causing that to do, you know, causing electronics to do that. Let me see here. There's no current draw and the starter does not rotate. What could the cause be, you guys? Anything, open field winding, broken brushes or springs, open armature coil. Interestingly, Donna Roberts is having her 2003 Camry brought in because she said the starter quit working. And she was able to bump the starter with something and to get it started several times, and then finally it got to where that wouldn't work. So it'll be the little blue Camry will be showing up here pretty quick. She already made a work order. Technician A says speeding up the armature will result in decreased amperage draw. Technician B says slowing down the starter armature will result in increased amperage draw. That's number 18. That's basically C. I will tell you this though. You remember what I was talking about the other day? How some of them Volkswagen Bugs, we would put a 12-volt system on there, but we couldn't change the starter. If that starter ordinarily drew, I'm just pulling the number out of the air. If it ordinarily draws a 6-volt starter, would draw 200 amps out of the 6-volt battery. And we put a 12-volt battery in there, the starter was spinning twice as fast and only drawing 100 amps. You know, it had more voltage to push, you know, that kind of thing. All right, so Technician A says speeding up the armature. Never mind, I've already done that one. Technician A says increasing the amount of current flowing through a conductor will increase the strength of its magnetic field. Everybody got that? You like that? A good answer? You like that? This is 2 questions in one, isn't it? Most people hate Technician B questions because it's like you get your work, you're giving twice the more work for your money, right? Technician B says coiling a wire around a soft iron core will increase the strength of its magnetic field. Both those guys are right. That's why your ignition coil's got a soft iron core in it. That's why this little solenoid in this relay has got a soft iron core in it. So anytime you want to make something really, really strong, you put a soft iron core in it and wrap wire around it, it's going to be stronger. Okay. Let's see, Technician A says the commutator is a series of conducting segments located around one end of the armature, and that'd be right here, that come in contact with the brushes. The brushes slide over these little suckers. That's it. Technician B says the armature is a stationary component of the motor that consists of a conductor wound around a pole shoe. This right here is an armature, and the armature always spins, guys. The pole shoe is basically these little things that fit around the side. The only starter, well, we've got a couple of starters out there under that bench that's got field coils. These little starter motors that they have on just about every car out there now has got permanent magnets. And the permanent magnets are just always magnetized. So that makes it cheaper to build because you don't have to wind that copper around those pole shoes. You know that? Hang on a second, stupid telephone. Hello? Hello? Hey. Anytime you can get it over here, we ought to be able to make it happen. Just whatever works for y'all.
This is the hour.
All right. Okay, that's a vehicle inspection. Let me see. Let's see. Which of the following represents? Anyway, have you ever seen these starters that's got big screws around the outside of them, like one big screw here and here and here and here? You know what I'm talking about in the barrel of it? Like right here. This is what I'm talking about, right over here. I'm gonna point at it with my laser. You see this big old screw right there? See it? That's holding that pole shoe. And that part right there is the armature, that part in the middle, but that pole shoe it's a big old piece of metal that's got copper wrapped around it. And all the current that flows through that starter flows in series through the windings going around those pole shoes and into the brushes. You got me? And that's basically creating a magnetic field around the outside. The brushes magnetize the armature, and that magnetic field runs from itself. And you can see that when you tear down a starter out here that's got one of those in it. That's not anything we need to hammer on right now, but anyway, so number 20 is basically going to be A. Which of the following represents the correct sequence of steps that may need to be performed when testing a starting system? A. Visual inspection, battery condition, voltage drop, and starter draw. B. Visual inspection, voltage drop, battery condition, starter draw. C. Battery condition, visual inspection, starter draw, and voltage drop. I hate these kind of questions, don't you? D. Visual inspection, battery condition, starter draw, voltage drop. That's going to be D. Visual inspection, battery condition, starter draw, and voltage drop. Voltage drop is typically the last test you'll do if nothing else has turned up a problem. I like doing it. You can do it in any order you want to, but the correct sequence of steps is to do voltage drop after everything else is cleared. Number 22. In the ISG, how does current flow to make the system perform as a starter? Anybody know that? Through the rotor to create an electromagnetic field that excites the stator, which causes the rotor to spin. Through the rotor coils, which cause magnetic field to collapse around the stator and rotate the crankshaft. Through the stator windings that generate magnetic fields in the rotor, causing the rotor to turn the crankshaft from the start generator control module. So the rotor coils are connected to the delta wound stator. That's basically going to be C. Now you remember on these hybrid vehicles, you got MG1 and you got MG2, right? MG1 is a small motor, MG2 is the big motor, and then you got a planetary gear set in the transmission, and you got in that one little planetary gear set, you've got the carrier, the planet carrier is bolted to the crankshaft on the engine. I mean, the sun gear is actually bolted to MG1, and then the ring gear is MG2. And I hope I hadn't forgot how that goes. But the long and the short of it is, that way the motors can spin the crankshaft and basically drive the car down the road if they need to, the little electric motors. The motor can also start the engine if it decides it wants to, and so on and so forth. And the electric motor sometimes turn backwards in a hybrid vehicle, depending on what range you're wanting to get out of that planetary gear set. So, anyway, short answer. List the 7 components of the starting system. Battery, cables, wires, ignition switch, starter relay, solenoid, starter motor, starter drive, flywheel gear, and start and safety switch. Can you remember those? Tell me the ones you remember.
Battery and cables.
That's
Wires.
all. Second-rate amateur.
Battery, cable, wires, starter.
And what's a part of the starter? One of these parts is a part of the starter. Solenoid, there you go. What else? Actually, 2 of them are part of it.
Battery, cable, drive, wheels, drive, wires.
Starter drive. Starter drive's part of the starter. Start and safety switch is going to be in there on the clutch or on the side of the transmission usually. Got that? All right, another. I need to give you all this a big, long, 50-question short answer test. Wouldn't you love that? List the 4 most common starter customer complaints. And how would you? Let's say this the right way now. We got to learn to communicate properly. Let's say I go out there and I get in my car and it goes with no laugh of its own.
Over, but no fire.
Huh? What? No fire. How do you know it's fire? Could be fuel.
Crank no start.
Yeah, cranks normally, but won't start. Cranks meaning. What are the two circuits found in the starting system called?
DC and AC.
Hmm? What about the starter control circuit and the motor feed circuit? The starter control circuit comes from where, guys? Where does the starter control circuit come from? Huh?
Solenoid.
Where does any control circuit come from? It comes from the switch that operates it, the ignition switch, through the neutral safety or clutch switch to the starter solenoid. That's your starter control. That's the primary side of the starter circuit, where the little wire is that makes things happen. Where the work is being done is the secondary side. That's the way it is on a relay. The primary side is your coil. The secondary side are your contacts that cause where the current flows. Got me? So remember, primary, secondary, primary, secondary.
So
That's the way that I'm going to say that.
the secondary one's the motor?
Huh?
You said the other name.
Secondary is the part that actually runs the starter motor. The primary is the part that comes from your key. That little wire that you're always checking, you know, the one that you jump your screwdriver to make it spin, you're actually artificially putting juice in there to make it. I'm going to tell you something else, guys. If you ever find yourself in a situation where you're trying to start a vehicle with a screwdriver by shorting those things across, you better triple check that darn thing and make sure it's not in gear, or it will run over you or somebody else. You know what I mean? I got a guy get killed out there in Malvern a while back when he started his tractor that way, and the darn thing was in gear and it ran over him and killed him. So he killed him, squished him under the big tire. But see, the thing about it is, he knew where the starter was, he knew where to stick that thing, but he forgot to check to see if it was in gear. And once that diesel starts up, it's gone, man. You know what I mean? It'll run all over you. And you can tell you something else you need to remember. If you're piddling around with the crankshaft area, you know, putting a rear main seal in or something like that, and you got that starter button like I gave you the other day, you know, you'd be really, really careful and prudent about that. You can lose a finger. Because I've known people losing fingers like that, horsing around up under that starter. The machinery don't know that you want it to stop. You know, it's going to keep going, you know. So, I mean, we haven't ever had any kind of a mishap like any of that here since I've been here. But, you know, you hear about stuff like that, and it's just really a bad scene, man. And just like the other day, like when Webb started that neon up and it tried to take off on him, you know. But that's because the shift cable was hung, and somebody decided to try to start it at the starter relay, and it was in gear. So you want to make darn sure. And what I did was, when we were going to be working on it the other day, we raised that sucker up and got it off the ground, put stands under, so it couldn't go nowhere. I mean, yeah, it may take off, but it's just going to be whirling the wheels in the air instead of, you know, driving over you, you know. Anyway, that's just spooky stuff, man.
Got me the other day too when we tried to crank that F-150. I forgot that it was on the ground, but luckily it just tried to crank it. It didn't. It was in the rain.
Yeah, well, needless to say, that engine that was in there wasn't going to crank. They are bringing us another one. It should be here today, you know. Willie's really happy about that. He gets to change the motor twice. I reminded him of how fast y'all got in swapping Abby's transmission out after you did it over and over a bit. It was a day and a half the first time. The last time he did it was 45 minutes. They had the thing out there. Yeah, that thing gonna be a stewed. But anyway, Daniel probably needs to help you with that because he's got a good shoulder now. All right, let me see here. Let's see. Where am I supposed to be?
What is this?
26. What's the name of the movable component of the starter motor? It consists of a conductor wound around a laminated iron core.
Starter drive? Armature.
Huh? What?
Armature.
Yeah, that's the armature is what he's talking about. This is a little armature from a window motor. I like to hold this because it's really pretty. You know, that's an armature. All right, it's an armature, a rank armature. Okay, number 27. What type of starter motor uses the characteristics of a series motor and a shunt motor? Compound motor, yeah. What part of the starter motor engages the armature to the engine flywheel ring gear?
The drive pinion.
Yeah, well, yeah, that's a good name, but you would call it a starter drive. The drive pinion is not a bad name for it. That's probably your parts book probably says that sometimes. You ever get crossed up with the mechanics because your parts book calls it one thing, they call it something else? We used to run into that at the Ford place all the time, and other places where I've had parts men. Guys, you need to establish a really good rapport with your parts guy.
Yeah.
I mean, you really, really do, because it's really it's important to be able to get along with your parts guy. And wherever you're getting your parts from, you and your parts guy need to be just like that. You know what I mean? Because that'll make all the difference.
Not that close.
Yeah. Well, not physically that close, but you need to be buddies. You know what I'm saying? You need to be really good buddies.
Okay, so the parts car
You know.
right now, I can't work in that.
And I have worked with a lot of parts men over the years, I'll tell you that. You
Taking
know.
long walks in the sun.
Yeah. I know, you know, I call up here to the,
Tipping up a beer.
well, it's like this, you know, if you know the guy, and you know he knows how to look up parts, and you know he's not gonna send you the wrong stuff, you know. And I was so terrified that day whenever I called up there and I said, I don't like talking to anybody I don't know. Who are you? Well, I'm just gonna be helping you. And I said, I need a lug nut for a Toyota. Listen to this. I need a lug nut for a 2006 Toyota Corolla. He says, front or rear? You're scaring me, buddy. You know, do we need to keep talking here? Well, just send me the one you got. We'll match it up. Okay, that I can do. You send your girl out here.
I like that.
Front or rear? Sometimes, if you ever ask them anything just to keep them thinking that you're digging or something, you know, just ask the question without thinking about it. And it's like a lawyer. Lawyers do that whenever they're trying to just run out the clock. They'll ask a question. I was backing up. Well, which way you were going when you was backing up? Well, I usually go backwards when I'm backing up. This kind of thing, you know. All right.
I like to step people up when I ask for brake lights.
Yeah.
I'll be looking it up and okay, is that from the front or the rear?
Yeah.
Or headlights?
Yeah. I always tell the parts guy when I call it the steering wheel's on the driver's side and it's white and this kind of thing, you know. All right, let me see here. What two types of magnetic switches are commonly used in starter systems? Solenoid and a relay, you know, they're magnetic switches. What type of starter motor has electrical connections that allow current to pass through the field coils and the armature? That is a series wound motor like I was talking about earlier, with those little pole shoes that are got that heavy stuff wrapped around them. 31. Describe how performing a relative compression test using a lab scope and starting circuit can determine internal engine condition. Whoa! What do you see there? You're going to put the amp clamp of the lab scope around the starter cable. With the ignition disabled, you're going to spin the engine over and you're going to monitor that scope pattern and you're going to look for any differences in the peak levels. Because if it's like it ought to be, what you're going to get, matter of fact, I think there's a preset on that scope out there for that. What you're going to get on a normal engine is peaks that look like this. Got me? All right. Hey, how you doing?
Eddie wanted me to come here and see if you had a torque bit to fix this
Yes, but it'll take me a minute before I can get it. Just sit down over there somewhere. But anyway, if you see one that's like this right here, I'll be there and I'll get it for you. All right. But if you got one that's got a low peak, or you got one that's got a high peak, it's either harder or easier. You know what I mean? This is actually amps. You see, if you got one that's not taking as much amps. Now, what did you hear on that engine that you pulled out of the F-150? You know, it ain't pulling as much current. Okay. Describe how the rotor turns in a three-phase AC motor. Wow.
With the engine.
Huh? No, three-phase AC motor. What's AC stand for?
Alternating current.
Yeah, so, okay, you got three power sources, each 120 degrees apart from one another. Right? 120 degrees apart. You got the three windings that are usually marked with some letters and all that kind of stuff. The rotor is pulled by the continuity of rotating magnetic field. So as it alternates in there, it's here and then it's here and then it's here and then it's here and it's here and it's here, you know. And it's going to however many cycles per second you're doing. The stator does not rotate, but its external magnetic field does change from pole to pole. You got me? So the magnetic field actually drives it around, and that's the reason. Why do we need to know that in the business of working on cars? Because that's typically like ceiling fans and stuff like that. Why do we need to know that? Because the motors I'm always talking about in the hybrid vehicles, MG1 and MG2, those things are AC current motors, and they got those three big. And so if you've got the battery, back there, look at here. We're going to do this for a second. You got the battery back there, your big old house of a battery that's got all of them things. It's actually going to go through two boxes. Right? One box is a DC to DC converter. One box is an AC. I mean DC to AC. And that's basically an inverter. And every motor in a hybrid, every AC current motor has got its own inverter. Wherever you've got a motor, you've got its own inverter. You don't just feed a bunch of power out of one inverter to a bunch of motors. You've got an inverter for every motor. And every motor's got a resolver, which is kind of a complicated thing to explain. That's probably why I'm not even going to try to explain it. But anyway, that's how that works. Number 33, define the current draw test. How are you going to do a current? Are you going to do a current draw test? I'm going to tell you to do a current draw test, and this is part of your final exam. How are you going to do it?
Look it up.
Please. You guys, what's this? You guys don't remember electrical 1? Come on, the ones of you that were in it. Yeah. So what you do is you're going to hook up your big terminals, the batteries. Then what you going to do, Daniel? What's the next thing you do? The curly cord. It's got the little inductive pickup. I'm going to put that around I'm going to put it either pointing toward the starter on the positive side or away from the starter on the negative side. And then I'm going to disable the ignition, and I'm going to look at that machine, and I'm going to spin it over, and it's going to tell me how much current. That's the
thing that
yeah.
puts around there.
That's
like
right.
that.
That's right.
Oh,
It's going to measure how much current. See, you guys weren't articulating. You knew how to do it. That's what gets me. I mean, I'm asking you how to do this thing, and everybody's going, duh, you know, basically. All right. List possible causes of excessive voltage drops either before or after the starter motor. What are some causes of excessive voltage drop either before? What about bad cables, loose or bad connections, faulty relays, or solenoids? On this Mustang that me and one of my trainers, well, you were talking about Ryan, the guy that's over there now, you know. We get this Mustang, and this is important now because it's got to do with this test that we're doing. We get this Mustang, and it's on the hook. All right, so you turn the starter, you turn it, listen to this now, it's important. You turn the starter to start. This Mustang wasn't that old. It wasn't even, didn't hardly have any miles on it. You turn the starter, you got nothing. Turn the starter, you got nothing. Just, you know, everything lights up on the dash, but you got nothing. All right, we check for voltage at the battery. He goes under the car, he goes to the solenoid wire on the starter, and he's hooked to the battery, you know, with the other end of his test light. He says, okay, turn it to start. That wire lights up. He takes and he checks to the big wire. You know, the big wire that comes from the battery, he sees that that's hot too. But we got solenoid lighting up, we got no power being delivered to the starter, right, through the solenoid. Well, we can't really, you know, what we're going to do is we're going to put a starter on it, right? That sound like a good idea to y'all?
Sure.
Now, the starter kind of, you know, he was a little clumsy in those days, and he wasn't all that good at working in tight places. We call him Spanky. He's a big, heavy boy. He put that thing on there, worked on that thing, worked on it. He's so excited because it was a Saline Mustang or something, that big, highfalutin engine that's got the signatures of the two guys that built it on it. When he got through, he hooked everything back up, just like it would. Didn't change a daggum thing. New starter didn't change nothing. They should have bench tested it when he pulled it off, but he popped another starter on it because they had one in the parts room. Okay, well, take the starter, you take the test light, and you hook that darn thing up to the ground on your battery, which is what you're going to do when you go check for power, right? And you touch the test light probe to the engine block.
That cable, that one ground cable under there?
And when you turn it to start, the test light lights. And I'm talking about you got it hooked between ground and you're touching the probe to the engine itself, to the block on the engine. And you turn it to start and the test light lights up. Now what's that telling you?
It's a bad ground.
The ground from the battery to the side of the block was, you know, the big cable that goes to the side of the block on that Mustang. It was not making continuity. And it wasn't loose, and it didn't look dirty, but the bolt that they used was anodized with something that was not conductive, and they had the block painted, and so it was, it was hooked up, and you could grab it, and it felt tight, but it was dropping every bit of the voltage. So we took the bolt out, and we wire brushed that sucker, and we wire brushed everything, and we cleaned it all up, and we put it back up. What's silly about that, a year later, he got another one in there and went through that same exercise. Didn't he? I mean, another car that was the same problem, didn't learn anything from the previous one, checked it, put a starter on it, just like it would. He did the same thing over again a year later. We have to remember this. Some people can troubleshoot really well and remember. Those are the guys that are sharp. Some people can remember but aren't very good at troubleshooting. And they fix a lot of cars just because they remember what fixed that one a while back. Yeah, see what I'm saying?
Yeah.
But I mean, being able to find out what's wrong and remember what you found. One day I worked on one that was cutting up some kind of a peculiar way. I can't remember what it was doing, but it had some kind of a strange, distinctive idle to it. And I found it really fast in like 90 seconds, and I fixed it, got that ticket off my clipboard, signed it off, everything was fine. And about 2 weeks later, another one came in doing exactly the same thing, and I forgot what I found on that first one. That made me so mad. And so I had to start all over because I found it too fast and it didn't burn in. Now the one that beats you up, that you have to really, really, really work on to figure out, those are the ones you'll remember from now on. But if you find it push, pull, snap, click, you may not remember that one next week. All right, now then, let's go on down here. We're almost through. Explain the operating principles of a solenoid shifted starter motor. Whoa. What about that? A solenoid plunger moves, the contact disc closes, current flows through fill coils and armature, and the armature rotates to turn the engine. That ain't really complicated. Okay, and finally, number 36, what are the two circuits of the starter system and how do they operate? This is an essay question, you guys. The components of the control circuit include the start portion of the ignition switch, the start and safety switch, if applicable, the wire conductor to connect them to the relay or the solenoid. That portion of the circuit controls the operation of the high current motor feed circuit. The motor feed circuit has heavy battery cables from the battery. You got those two big terminals in the starter I was talking about. You got the copper disc that closes them up. And that portion of the circuit delivers high current from the battery to the starter motor and to convert electrical engine. Now, if somebody asks you, let me ask you this. If you go to apply for a job somewhere, and this guy says, well, I need to see if I'm going to hire you or not, so I want you to explain this to me. I'm not going to hire if you can't explain to me how a starter, what happens when I turn the key, what happens in the starter circuit area. You got to be able to explain it off the top of your head, no notes. Go. You know, you got 90 seconds to tell me how the starter works, and you got to do it to my. Now I'm going to pay you $26 an hour, but before that, I need to know you can. I need to know, you know, that you can even tell. All right. So, all right, that's pretty much got that all handled. You guys happy with that? Did you learn anything? What's that? No, you just got to think about it. You got to kind of have it in your mind, you know. And what if somebody does this? What if they throw you a little test? And I've done this before. People come and they'll say, you know, I want to come to work at your shop, and you may be wearing a mechanic's uniform. They say, what can you tell me about EGR and why it's there? Explain the operation of the catalytic converter. Tell me what happens when you turn the key to start the car. Can you tell me this stuff? You know, well, I don't know, I can fix them, but I just don't know how to say all that, you know. Nah, we need somebody that's more articulate than you are, because you may have to explain something like this to the customer. You see what I'm saying? I mean, so you better be able to list, define, explain, guys. It's really important to be able to do that.